So this is the 2016 Junior Cert Higher Level Paper 2 and we're looking at question number 12. Part A says a packet of sweets is in the shape of a closed triangular base prism. It has a height of 8 centimeters and a triangular base with sides of length 4 centimeters, 4 centimeters and 6 centimeters. So here's the prism here. Construct an accurate net of the prism. Show all your construction lines clearly. Well, a net is when you fold the shape out into all its sides and lay it down flat. So I'm going to start then with this slant side here. So this slant side here is got dimensions of 8 by 4. So I'm going to start by drawing that. So if I go from here, so if I draw 8 centimeters. Now, on your drawing, this will look a bit different, probably bigger, because my ruler is scaled down to fit the screen, so don't worry about that. But that's 8 centimeters here. Okay, and if I then turn the ruler vertically, and from there I'm going to draw down to 4 centimeters. So 1, 2, 3, 4. So I'll just complete that here. This side. Down to 4 again, level with the 4 there. And then finish that off. So that's this side here done. And if you folded that down flat, I'm going to draw the base next underneath that. So the base would be base is 8 by 6, so it's 8 across, so this time it's going to be down 6 here. So it would be from here down to 6, and it would be the same over here. So you can probably draw it a little bit neater than I can here. Again, down to 6 there. So again, we can flatten this up, draw this down, and draw that line across. Okay, and then finally the other side down here, which would be the same as this, the other slant side, would look like the following. It would be 6 again. So if we just extend the page, this time it's going to be 4 again. So we'll go from here down to there. So again from 4 and then finally we're just joining these up. So there we have the two slant sides and the base drawn in, not very accurately, but you can do this a bit more accurately. So now all that remains is to draw the two triangular ends. So I'll just label this, that side, base, and then over here the other side, laid out flat. So if we were drawing the ends then, the triangular ends, you can draw them off the base. So this is our 6 centimeter side, so we need the two 4 centimeter lines coming out. So the best way to do this is to bring the compass and stretch the compass out to 4 centimeters. Take the compass, put it here, and swing an arc, and then take the compass and put it here also, and swing an arc. And where the two arcs meet, they would be 4 centimeter lines. So again, we'll do this over here. Switch sides here. So from this point, we swing an arc, and again from this point here, swing an arc, and then we're just joining. I'll do this in blue as well. So we're joining from the base to there, and then back over here, and from the base to there, and back over here. So that gives us the net of the shape. So if you folded that back up, that would be this three-dimensional object here. Okay, part B. A different triangular base prism has the base shown in the diagram on the right. So we have a base of 7 and 70-degree angles here. This is x. Part 1 says use trigonometry to find the length of the side marked x. Give your answer correct to 2 decimal places. Okay, so the easiest way to do this would be to split this isosceles triangle here into 2 right angle triangles. Now you know it's isosceles because this is 70 degrees and this is 70 degrees. So we know if this is x centimeters that this over here is the same, x centimeters, because it's an isosceles. But if you drop this line down creating a right angle triangle, and we now look at this triangle on the left only, so the one here that I'm highlighting here, let's just look at the triangle here in yellow. That's a right angle triangle, okay? And on that right angle triangle, we have this angle, and we know that this length here will be half of the 7 centimeters. So that will be 3.5 for this length here. So in a right angle triangle, if we have a length and we have an angle, we can use this information to find one of the other sides. So from the position of this angle 70 degrees, this side here would be the adjacent, and this side here opposite the 90 degree would be the hypotenuse. So if you have the adjacent and you're looking for the hypotenuse, that's A and H, so that would be the cos. So we can set up this trigonometric ratio. The cosine of the angle, 70 degrees, is equal to the adjacent, which is 3.5, over the hypotenuse, which is x. So cos 70 is equal to 3.5 over x. So if we're looking for x, if this number cos 70 is 3.5 divided by x, well then x would be 3.5 divided by cos 70 degrees. So when we put that in a calculator, we get 3.5 over cos 70, and make sure your calculator is set to degrees, not radians. Okay, that gives us a value of x equal to 10.2333, and on it goes. But we only want the answer correct to 2 decimal places, so we're going to look at the third digit after the decimal, the 3. Does this 3 affect the number in front, the 3 in front? Well, the answer is no. So we know that x would be equal to 10.23, correct to 2 decimal places, and that's a length, so that's centimeters. So there's our x value to 2 decimal places. Okay, part 2. This prism is shown in the diagram on the right. So this is the prism, the face of which we just looked at here. It has a height of 12 centimeters. 3 of its faces are labelled A, B and C, and we're asked to find the area of each of the faces labelled A, B and C in the diagram. Okay, well, shape A, or the face A rather, is a rectangle, and it's 7 by 12, so length by the width of a rectangle, 7 by 12. So that gives us 84 centimeters squared. Face B was 12 times x, so 12 by x. Well, we just worked out x. X was 10.23, corrected 2 decimal places. So we can work that out. 12 by 10.23 gives us an answer of 122.76. But we wanted correct to the nearest centimeter squared, so we can say that's the nearest centimeter squared. Well, we look to the first digit after the decimal. Does this affect the 2 in front? Yes, it does. Knocks it up to a 3, so it's 123 centimeters squared. Okay, which just leaves face C. So face C is a triangle. So the area of a triangle is a formula again to be found in your tables book. So when you find it, there's a number of formulas, but the one we're using will be this one here, where the area is equal to a half times A times H. And you can see from the diagram, A is the base and H is the perpendicular height. So if we're looking at this triangle here, we know that this base here is the same as that, so that's 7, that's the base 7 from the previous diagram. There is 7, and we know the value of x, but what we need is the perpendicular height. So we don't need x, we need the perpendicular height. So how do we find this perpendicular height here? So that perpendicular height would be the same as this height here. So we're looking, that's a 90-degree angle there. We're looking for this blue line here, this height here, which is effectively this line. So if we look at this triangle here, it's a right angle triangle, so we can use Pythagoras. So the square of the hypotenuse, x, which is 10.23 squared, we know that's equal to this side here, which is 3.5 squared, plus the height we're looking for, which I'm going to call y. So that's the height y, plus y squared. So if we rearrange this, we bring this 3.5 squared over here, it becomes a negative 3.5 squared. So that gives us a y squared is equal to 10.23 squared minus 3.5 squared. Well, then y will be the square root of that. The square root of 10.23 squared minus 3.5 squared. So when we do this on the calculator, we get an answer of 9.612, and on it goes. So 9.612, that's going to be this blue line here is 9.612, that's our height. So the y is 9.612 ... Well, we want the area, so the area is a half AH, and in our case that's going to be a half, A being the base, which in our case is 7, so half by 7 by the perpendicular height, which we just worked out, 9.612 ... So that gives us a final answer of let me just try that again. $33.642, and on it goes. And if we're looking for the answer to the nearest centimeter squared, that's going to be equal to, if it's the nearest centimeter squared, we look at this 6, does it affect the 3 in front? The answer is yes, it does. It knocks it up, so it's 34 centimeters squared. And that's the end of question 12.